Good afternoon, good afternoon, good afternoon. I'm Dr. Kelvin Mackey of STEM Nola, and welcome to STEM Nola at Home. We are grateful and thankful that you all have tuned in once again on a Thursday afternoon. Who'd ever thought when we started this, I guess last April 2020, post-COVID, that we'll still be going on and doing it now after reaching thousands of young people across this country in 47 states and now 5 different countries. Just sometimes, I have to pinch myself and remind myself that dreams do come true. Scholars, that's what we want you all to know. That's why we do this. We want you all to dream about the possibilities of the 21st century. I believe we need to have a radical imagination. A radical imagination is not imagining what is. A radical imagination is imagining what should be. And when you're exposed to science, technology, engineering, and mathematics, your imagination can take you to anywhere that you may think you want to go. That's the possibility. That's the self-agency of science, technology, engineering, and mathematics. I'm excited about today because we have a registered nurse from our partner, Oxner Health Systems, Dominique Gianci, here today to present to you. We have another one of my good friends, Dr. Eric Griggs. I'm not going to rag him today, but he got his medical degree from Tulane University to also do something for you. So we are ready, set, and loaded and locked to get this thing accomplished today. Parents, we do this. We do this because in the 21st century, your children will have only 1 or 3 options. Either they're going to take something, break something, and/or make something. And if we don't give them the skills and the education and the inspiration to make something, like make a living, make a life, make a difference, that only leaves them with the 2 options that we see on the news every night, and that's to take and a break. And we don't want that for any of our young people in this country. America is transforming right before our eyes. And I'm not talking about the demographics of America. I'm talking about the career opportunities in America. COVID has accelerated this thing called automation, and every day corporations and companies are sitting down trying to understand how do they automate their processes. We're going to be talking about biology today, but even if you want to be a doctor, technology is infusing health, and health tech is now a big area. If you want to go into agriculture, ag tech is a big area. So no matter whatever you're going into, technology is transforming it. And in the 21st century, either we're training ourselves from the neck up or we're training ourselves from the neck down. If we're training ourselves from the neck down, our competition will be the automatic machine. And before me, I have a humanoid. A humanoid is a robot that tries to behave like a human. This is Alpha. And Alpha can do all of the physical things that you can do. Alpha can do push-ups. Alpha can even show off like you. And you see all the places we have joints, we have servo motors there, and we could program those motors using coding and talk to the robot using Wi-Fi. Alpha can even dance. All right, Alpha, that's enough. That's enough, Alpha. Get Alpha a hand. Yes, Alpha is a humanoid. Now, a humanoid is a robot that tries to behave like a human. This humanoid is built by a company called UB Tech Robotics, the largest commercial robotic build in America. And right now, UB Tech is building life-size robots and machines to do the work that we thought we would be doing physically. So in the future, either we're going to control the robots or the robots are going to control us. The only way we control the robots is by training our hearts and training our minds. I published an article 2 days ago in Forbes magazine about the heart and the mind aspect of STEM and how it is not enough for us to become proficient and efficient at being great technologists or scientists or mathematics and engineers, but we got to develop our empathy for people. When Miss Dominique come up, the nurse, she has to be very empathetic by being a nurse. And sometimes we think when we become scientists and engineers, we could just forget about this people part. Well, you know what? That's the part that's going to separate us from the machines. And that's why we have to focus on not only the head, but also the heart. We have to learn how to work together, but more importantly, we have to learn how to live together. And that's the way we build a better world. Now, today, we're going to focus on biology. I want to acknowledge the young people, the scholars who sent them pictures from last time. Remember, we need pictures from you all to keep this thing going and keep it free, because we have sponsors, and the sponsors want to see the work that you all are doing, because it's not that they don't believe that you all are engaged, but we just need proof that you all are engaging and doing the things that you're doing. So we appreciate the pictures mailed to webinar@stemnola.com. My friends Shayla Washington and Lacey Jasmine, who are homeschooled in Shreveport, thank you. I hope you all participated in STEM Shreveport. If you didn't, go to stemnola.com or stemgrambling.com and sign up so we can make sure you don't get on the mailing list to get the stuff coming to you. My friends Elijah and Jacob from Hopewell, Virginia, thank you all for sending in a picture. Those are some nice edible circuits. That's a nice edible circuit. And my little friend, Javen Moore from Cornersville, North Carolina, thank you. That's a pretty circuit also for sending in your picture. Now, I'm going to introduce Dominique Gianci, who's a registered nurse and a unit director for the medical telemetry. Look at me. Sometimes I impress myself. Telemedicine step-down unit for Atrium Health Systems. Dominique got a BS in biology from Xavier University right here in New Orleans, and a BS in nursing from Louisiana State LSU Health Systems here in New Orleans. And she got a MS in nursing at Loyola University. So, Dominique Gianci. Remember, you all, wear your mask. Mask up, COVID down. Dominique.
Hello, everyone, and I'm here to talk about how I got into nursing. My name is Dominique Gianci, and I work for Atrium Health System. I'm a registered nurse there, and my title there is I'm a director of a nursing unit at Atrium Health. So at Atrium Health, I'm over a 34-bed unit of medical and telemetry patients. So you might say, well, what does the medical and the telemetry piece mean? So let's go all the way back to how I started in biology, which is the life science, and how it kind of geared me towards nursing. So biology kind of gives you a big spectrum of things that you can do in your career. So went to Xavier, wasn't quite sure what I wanted to do. So I finished my first degree in biology and then went on to nursing school. And nursing is all about the life of a person, all about how we can be, like Dr. Mackey said, be empathetic and connect to people's hearts. So nursing is about connecting to people's hearts and communicating with them in a way that they can understand about their health and what it means to be promoting their health throughout their lifespan. So you heard me say that word, telemetry. So here on my unit, we attach electrodes and leads to patients to monitor their heart rate and rhythm. It gives us a guide to when patients are coming in, maybe with the kind of short of breath, or maybe their heart is beating real fast. It gives us an opportunity to see what's going on with the electrical conduction of their heart. So yes, I'm a nurse, and yes, I do connect to people's hearts and speak to them and communicate with them and being empathetic. But the other piece of it is technology helps us a lot in what we do for our patients on a day-to-day basis, whether it be just connecting the electrodes to them or talking to them.
I don't have the mic. And next up is Dr. Eric Griggs. Bring the mic, Griggs. Next up is Dr. Eric Griggs to talk about the heart. Eric went to a little school named Notre Dame, where he played football, and now he's a community health medicine doctor here in the city of New Orleans.
Thank you, Dr. Mackey. Hate and all included. My name is Dr. Eric Griggs. I'm a community medicine doctor down here in New Orleans at Access Health, Louisiana. Today, we're going to talk about some fun stuff. You just heard about telemetry. I wish I had one of those. No? No. Today, we're going to talk about the heart. I want everyone to take their hand and make a fist. And I want you to look at your fist and understand that your heart is the size of your fist. There it is. Your heart is the size of your fist. Couldn't find my one. And I know everyone's going to do this. You have an individualized heart. So I want you to repeat after me. Your heart has four parts. A right atrium, a right ventricle, a left atrium, and a left ventricle. Ooh. Ah. Ooh. Ah. Your heart has four parts. A right atrium, right ventricle, left atrium, left ventricle. Ooh. Ah, give yourselves a hand. That's very good. So what we're going to do is we're going to do a dissection right after this. And I want to reinforce to you that they're the four parts of the heart. The right side of the heart works with blood without oxygen. The left side of the heart works with blood with oxygen. The veins come into the right side. The arteries go out the right side. But there's a little dance, I think, that can kind of help you out. So I want everybody to stand up, stretch, belly rub. Yeah. Good. Yeah. Stand up. All right. Blood comes into the right atrium. Then it goes down to the right ventricle. Stomp your foot. Then it goes back to the lungs for oxygen. Then it comes to the left atrium. Then it goes down to the left ventricle. Then it pumps out to the body. And then you dab because you know what you're doing. Let's try it again. Our blood comes from the vein with no oxygen. It comes to the right atrium. Then it goes to the right ventricle. Then it goes back to the lungs for oxygen, spirit fingers. Then it comes to the left atrium. Then to the left ventricle. Then out to the body. And then you dab. Was that cool? Well, even if it wasn't. Was it fun? It was fun, right? Yeah, you know, ooh. Ah. Yeah, that's good. So we're going to learn a lot. Lamaya's going to be up next. We're going to go through, you're going to cut through an actual sheep heart. The white stuff on the outside is fat, and you'll see the atria, remember the atria, and the ventricles, and understand that the heart works together to pump blood all the way throughout your body. Thank you. Thank you. My voice is changing. Thank you very much. Lamaya, you're up.
All right. Hello, everyone. It's been a while. My name is let's take my mask off first. My name is Lamaya Hall. I'm the operations coordinator here at STEM Nola. I have a BS in biology from Xavier and a master's in public health from Xavier. And I'm also in the process of interviewing for medical school. So I actually had an interview this morning. I got my second win for the live session today and to talk to you guys about hearts. So the first thing we're going to do is we're going to go over our agenda for today. So the first thing we're going to look at are some vocab terms. Then we're going to talk about some objectives. So our purpose for being here, the meaning of us being here. Then we're going to go over our activity questions. Then I'm going to show you guys a real heart dissection of a sheep heart. Then we're actually going to build our own heart pump. And then we'll review our activity questions. And I'll give you time, guys, some time to ask me some questions as well at the very end. So our first vocab word today is atrium. So atrium, these are thin wall chambers that receive blood from the veins, right? So then where does this blood go? It goes to our ventricles. Ventricles is our second vocab word. These ventricles are actually thicker, the walls are thicker because they forcefully pump blood out of the heart. So think about this as muscles, right? Our atrium is doing less work than our ventricles. So that's why the walls are thinner in our atrium than they are in our ventricles. So
Our next vocab word is our heart, right? So what is our heart? We talked about the atrium and the ventricle part of the heart, but what is actually the heart? It's a muscular organ in most animals which pumps blood throughout the body, right? It pumps blood throughout your blood vessels, and it's a part of your circulatory system. And they call it a circulatory system because literally your blood makes a circle in your body. So our last vocab word is circulatory system. It's a system that circulates blood and other nutrients and lymph through your body, consisting of your heart, your blood vessels, and other parts of your body that circulate through. And like I said, it's a circle. So that's where you hear the word circulatory from. So our first poll question, these questions are going to pop up throughout today's session. So go on ahead and answer this first poll question. It's called the circulatory system because the blood ultimately flows how? Does it flow in a quadrilateral? Does it flow in a circle? Or does it flow in a diamond? Let's go on ahead and get those answers in. I'll give you guys a couple more seconds to submit those answers. Perfect. Our blood flows in a circle, which is why it's called the circulatory system. So let's talk about our objectives of today, right? So we want you guys to understand the meaning of the terms blood vessel, heart, circulatory system, and atrium and ventricle, and apply them to the project today. We also want to be able to examine the human body, look at a dissected heart, and actually build our own small heart model replica. So our next poll question today, what are we building today? Are we building a clock, or are we building a heart pump, or a race car? I hope we're building a race car. I really do. I've been wanting a race car, guys. See, somebody voted race car for me. Well, looks like we're building a heart pump. I love the heart. I'm excited about this one. Race cars are cool too. So maybe we'll get to that one day in a live session. So let's look at these questions of the day. Basically, I just want you to look at these, think about them, keep them in your brain as you're doing your experiments and watching the dissection and stuff today. And we'll answer them actually at the end. So our first question is, what do the straws represent in our heart pump? Our second question is, what pushes from the atrium to the ventricle on each side of the heart? And our last question is, what is the circulatory system? So remember, just keep these questions in your head as we're going through today's session. You can take a screenshot, scribble it down right quick, something, but we'll answer them later. They'll come back up on the screen. All right, so the first thing we are going to do today is we are going to get into our heart dissection. So the first step is putting on gloves because I'm not touching this heart without gloves. That's just not right. So first I'm going to put on my gloves. And it's not a good thing to wear rings while you're wearing gloves because your rings can put a hole in your glove if you have a big ring. But I'm not too worried about that today. So this right here is called a scapula. A scalpel. I don't know where scapula came from. It's called a scalpel. I'm sorry, guys. So what I'm going to do is open it from the end where the handle is, and you can actually pull out, and the scalpel comes out. So this right here is our sheep heart. I'm going to open the pack here. And remove it from the package. So as you can see, this right here, like Dr. Griggs was talking about, this kind of yellowish white on the outside of the heart, that's just fat. So we don't want a lot of fat on our hearts because guess what's going to happen? It's going to make it work harder. So if our heart's working too hard, it can damage our heart. It can cause other health complications. So we want to keep this fat on the outside of our heart, actually, as like not have a lot on there, right? So I'm going to make 2 cuts today. The 2 cuts I'm going to make are going to show you the ventricles. Atrium kind of means window of space, so you can't really see them as much as you can see the ventricles. So we talked about it. I want you guys to throw in the chat. Does the blood flow through the right side first or the left side? Remember, we just did the dance with Dr. Griggs. So did it flow? Did we talk about the right side of the heart first or the left side? That is correct, the right side of the heart. So this right here is the right side of our heart. And I'm actually going to cut that side first. So when you actually look at these ventricles, they're a lot thinner than when you see our left side, because our right side of the heart, it goes to the lungs, right? So as you can see, when I cut this part of the heart, this kind of window of space right here, you see the walls. You can see the walls here. It's kind of just like a empty space if you just kind of hold it. And that is your right ventricle here. So this right ventricle seems so small because this ventricle is only pumping blood to your lungs, right? And your lungs are really close to your heart. So the blood doesn't have to go far. But let's check out this left side of the heart. So when I make this cut, I'm actually going to curve it around to what they call the apex. So the apex is the bottom of the heart. And these walls are actually pretty thick. So when I open it, there is going to be some juice that comes out. It's a bigger window, empty space. You see how thick the walls are here. And that's because this side of your heart is doing all of the work, right? The left side is the side of your heart that's pumping that oxygenated blood throughout your entire body. So just imagine, okay, the right side's only going to the lungs. It's going to one place, right? So it's going to have smaller muscles. Think about lifting weights. That may be lifting a 2-pound weight, right? That side of your heart may be lifting a 2-pound weight. But this left side of the heart is pumping throughout the entire body. It's supplying your entire body with the blood, the oxygenated blood that it needs. So guess what? This one's lifting a 50-pound weight. So guess what? Our muscles are going to be thicker. Our walls are thicker because our heart is a muscle. And it's going to also take up more space too because we have more muscle and more mass here. So the atriums, they lie at the top, but it's truly like a window of space. So it's not, you can't really see it. The largest artery in the body is called the aorta. And if I stick my finger here, look, you can see it on the left side of the heart. That's how you know you're in the aorta. So the blood will flow from this ventricle up through where my finger is, and it'll pump blood throughout your entire body. So through your arteries in your body. So that is our heart dissection with our sheep heart. It's not a live sheep heart, but it is real. The sheep donated his body to science, and so you guys can learn. So let's take off our gloves and let's move on to our heart pump. So if you have your materials already, I'm going to call out your materials first. Then we're going to go over the science behind what we're doing today, and then we'll actually start on our experiment. So the things that you need a cup of water. It can be room temperature. It doesn't have to be a certain temperature. You need 1 balloon. You need 2 straws. Make sure they're bendy. Well, they don't have to be bendy, but it's a little better with a bendy straw. Scissors, tape, a skewer or a toothpick, red food coloring, and a foil pan, or like something for the liquid to flow into when you're pumping your heart. So as you're gathering these materials, let's go over the science behind it. So your heart contains valves which direct the flow of blood in one direction, right? So it doesn't allow for something called backflow. So what happens is these valves they open up when your heart, when enough blood gets into your atrium. They open up like swinging doors and close back, so that the blood can flow from the atrium to the ventricle. And they close back to where the blood can't go from the ventricle back up to the atrium, which is what they say that prevents backflow. So through this experiment, we'll be able to easily understand the mechanical action of these valves of our heart, right? And blood is forced through the flexible membranes of our valves. So once the blood passes through the membranes, the valves collapse, which means that they open and then they close again, preventing the blood from flowing backwards, like I said earlier. So the walls of the heart are made of really strong muscles that squeeze and relax to pump the blood throughout our body, and blood is pushed from our atriums to our ventricles, from the right side to the left side, then all the way out to our body. So let's go on ahead and start on our experiment today. So the first thing that we are going to do is we are going to make our water. I have a small bottle of water here. It's cool if you have a cup of water. It all works the same. So what I'm going to do is I'm going to mix my food coloring in my water. And you don't have to have food coloring either. It's just red to represent the blood, so it's not necessary to have it if you don't have it at home. So I'm just going to drop a couple drops of food coloring in here. More than a couple, because sometimes if you don't put enough red, it looks pink. And I want to make sure my blood looks red. All right. So I'm going to put the top on my water, and then I'm going to shake it just to make sure the food coloring is mixed in. If you have like your straw, you don't necessarily need a spoon. If you have the straw, you could take the straw, the toothpick skewer, whatever you have, and just mix it, the food color into the water. So, okay, we have our water now. So what I'm going to do next is I'm going to pour just a little bit, maybe like 2 or 3 inches of water here into my cup. So I'm going to give you guys a couple seconds to do that. All I did, the only 2 steps I've done is I mixed my food coloring in my water, and then I poured about 2 or 3 inches of water into my cup. I have a 9-ounce cup. Some people, you may have like the small Tupperware containers. You can use those, like the ones you could put like sauce in. Those work as well. If you have like small Tupperware containers, that will work. So our next step, we're going to take our balloon. It doesn't matter which color. I'm just going to use red because I'm already here with the red. And we're going to cut off this tip here, right here. So we're going to cut off the part where you blow in, and you cut it about midway down the neck. So you should have your balloons that look like this. Like this. So I'm just going to show y'all one more time from here. I took my balloon, stretched it a little bit because balloons are a little easier when they're stretched. And I'm just going to take my scissors about midway and snip. So now I have the kind of the lip of the balloon where you blow, and then the actual balloon that expands right here. So our next step, we are going to stretch the balloon all the way around our cup. So what I'm doing is I'm putting my fingers into the balloon and I'm stretching as far as I can go, which I may not have cut enough off of this bottom part because it's not stretching as wide. So what I'm going to do is, if it won't stretch across the top of your thing, just cut a little more off so that you can have the wider portion of the balloon. Like I just cut like just a little tip off so that this balloon can stretch a little wider because this cup is really wide. So now, as you can see, this balloon can stretch wider. And I'm just stretching it literally around the cup. And it fits perfectly, snug, like a glove on top. I can't lean it too much to the side, but this is what the sides look like. There we go. So the sides here, this is what this looks like here. And I literally I had to cut like a little bit off of the tip, just about that much, so that I could have the wider portion of the balloon. So I just cut it like that, a little more. Stuck my fingers inside. I stretched it out. And once I stretched it out, it just fits exactly on top of the cup that I have the food coloring in, the food coloring and water in. So our next step, we are going to take our skewer. You can use a toothpick, just something with a pointy end, and we're going to poke 2 holes side by side in our balloon. So don't put them too close. And you don't want to make the holes way too big. So I'm going to poke one here, poke one here. And then I'm going to put my 2 straws into my holes. I may need to make this hole a little bigger. Just like this. Put the straw in here. Oh. Nope. This one's not as easy. There it goes. I was going to say that one wasn't as easy as the other one. So what I'm going to do next is I'm going to take the neck of that balloon that I cut off, the part where you put your mouth, and I'm just going to take a piece of tape and tape it onto one of my straws. Now I have some tape, brand new roll of tape, and tear off just a small piece of tape. You don't need a lot at all. And I'm just going to take this here, put it onto the straw, and tape it. You may have to fold the balloon a little bit just to make sure it's taped correctly. Mine's a little not neat at all, but it's okay because it all works. That's all we care about. All right. So again, what I did was I poked 2 small holes in the top of my balloon. Once I poked 2 small holes in the balloon, I put my straws in those holes, and then I taped the tip of my balloon onto the straw. I'm going to give you guys a couple seconds in case you need to catch up on that to get those steps down. So the way that our heart model works, I think my straws are actually too long. So I'm going to snip some of this straw off. And it just fell on the ground, which is fine. So when I push to pump, the blood is going to pump out of my smaller straw. Like it did at the beginning. There we go. So what's happening is me pushing down on the balloon represents your heart pumping, right? So your heart contracting. So what happens when your heart contracts is that blood goes somewhere else, whether it's to your ventricles or to your lungs or to the rest of your body. So when that heart pumps, put a little more water. And put a little more water through this hole so y'all can really see. Look at that. The holes are perfect for adding more water. So when I pump my heart and I really push, that blood is flowing and pumping to nourish our body with those nutrients that we need. So like we said, our heart, our straws here are representations of our valves, right? So when there's enough pressure to release, these valves open up, which allows for blood to flow out. And I just got our blood all over our table. So that's what our straws represent, right? So remember, our circulatory system, it goes in a circle. So the blood that leaves your heart and goes to your body, all it does is recycle and come back to your heart, because it needs to go to your heart so that it can get to your lungs to get more oxygen, so that it could go back to the other side of your heart, go back to your body, replenish your body again with the oxygen and nutrients it needs. Then it literally just keeps recycling, right? So it's a cycle, it's a circle, which is why, hence, circulatory system. And our straws represent our valves, right? So that they allow for blood to flow through them when the pressure is right, when it's time for the heart to pump, those valves open and close to allow that blood to flow through. And when we think about what goes from the right atrium to the right ventricle, what goes from the right, what's traveling on both sides of the heart from the atrium to the ventricles, right? It's our blood. Our blood is what's traveling through our heart. It's going on the right side, its goal is to get oxygen, right, in it. When it goes to the left side, its goal is to deliver that blood throughout the entire body so it can supply our body with the oxygen it needs. So let's go back to our questions. Let's review our questions again. This time you guys will actually be able to answer them. So let's start with our first question. What do the straws represent in our heart pump? That poll is going to pop up on the screen. Does it represent blood? Does it represent valves? Or does it represent water? What do those straws represent in the heart pump? Give you guys a couple more seconds to submit those answers. Correct. Those straws represent our valves. So our second question, what pushes from the atrium to the ventricle on each side of the heart? What is it that's flowing through the heart? What do we have that's flowing through the heart? Is it cotton candy? Oh, that's my favorite. Is it blood or is it coffee? Sometimes I think coffee runs through my heart. I get a little excited. Give you guys a couple more seconds to put those answers in. That is correct. Our heart, what's flowing through our heart is our blood, right? So our last question, what is the circulatory system? What is the circulatory system? Does it help us hear? Does it help us move our toes? Or does it circulate our blood? My circulatory system helps me move my toes. Sometimes they fall asleep and you got to wiggle them a little bit. Give you guys a couple more seconds. That is correct. Our circulatory system circulates our blood throughout our body. So I want to thank you guys again for participating in this STEM, what is the STEM at home session? I appreciate y'all's participation. I hope you enjoyed the dissection. I hope you enjoyed the heart pump and use that and learn from that because your heart is important. Working here and doing the dissection and activities like this actually helped me in anatomy when I was in undergrad. So it did help me pass my circulatory system test. So if you don't have any questions for us, I'm gonna call Dr. Mackey back up and he'll close out for today. Thank y'all.
Let's give Lamaya a hand. Parents, one thing I didn't say when we started, that STEM Nola has created what we believe is a high-functioning STEM community. A high-functioning community is child-centered, adult-governed, elder-ruled. The adults in our community are the college students that we hire as college interns. And then the elder in our community is the STEM professionals that we invite to volunteer and share with the young people. So at any given time, we have vertical mentoring. So the scholars today, they can, they can see their colleagues, their compadres in first, second, fifth, sixth grade, but they got to meet a professional and Miss Dominique Gianci. Let's give Miss Gianci a hand. Thank you, Miss Gianci, and Oxygen Health Systems, which is one of our main partners. So we had a professional, and you had Lamaya, which is our, she's now on staff at STEM Nola. She's amazing. She started working here as a sophomore. Now she just finished her master's and about to go on to medical school. So she's been here about 4 or 5 years. She thinks she run the place, and I work here. But, she's been great. So thank you, Lamaya. So coming up, and in the last 7 years, we put over $1 million in the hands of college students because we want them to make their mistakes here. Young people, when you got people who care about you and care around you, you make your mistakes in front of them, they correct you, so when you go out into the world, you won't have to suffer those type of losses. And that's what we're doing with you. We're giving you hands-on experience so you can learn, so you can be more prepared going forward. With our college students, giving them an opportunity to present and speak so they get out in their careers and profession, they have that experience. And we're introducing you all to the possibilities of the 21st century. Remember, email pictures to webinar@stemnola.com. We love the pictures. When we go back in person, we love to have these pictures, and we bring out and we put them in the rooms, and we like you see yourself. And you might see yourself on our website at stemnola.com, on our Facebook or Twitter, which is STEMnola, and our Instagram, Twitter. Our Instagram is STEMnola too. Twitter is STEMnola. I'm getting tired. So our next upcoming events is STEM Grambling in the Shreveport area on March 6th, and the topic for that event will be, what is that event? Math. Okay, so the topic for STEM Grambling on March 6th is mathematics. Yes, we can make mathematics fun, and we make math hands-on. In the past, we used to do all these different mathematical activities and cryptology and coding and different cybersecurity, and you used to build a tetrahedral kite. Yes, a 3-dimensional kite. And we would go outside and fly the kite. The kids this time, we're gonna have a surprise for what you're gonna build, and I think you're really gonna like it. Hands-on means minds on. In Central Louisiana, STEM Alexandria in the Fort Polk, Alexandria area on March 6th. We'll be having a STEM Saturday in Central Louisiana. Now, if you're in Central Louisiana, we want you to register for this and tell your friends. And what is the topic for Alexandria? So, okay, I'm doing that on purpose. The topic for March 6th in Central Louisiana is mathematics. And STEM Nola, that registration will be opening soon. And it's, again, going to be a mathematics day. And that's March 13th. And that's open to anybody in the USA. That means you. It's free. You have to pay a small shipping and handling fee. We had some challenges this past Saturday because of the weather and everything that's just been happening in our country, but we do our best. We make a mistake, blame it on our head and not on our heart. Our heart is in the right place. Now, again, we had a great day. And for you, those of you who participated in the STEM Saturday and made the floats and sent us pictures and videos, thank you. We're gonna be releasing, I believe we released the video already online of the different floats. That's an amazing parade. Like I told the mayor, Mardi Gras New Orleans might have been canceled, but STEM NOLA made Mardi Gras happen. So I'm Dr. Kelvin Mackey. I look forward to seeing you all next Thursday. I look forward to seeing your pictures, and you all keep pushing. Thank you and good evening.